So our genes are female, and as a tradition, I have to start with this. I was speaking about this lady who is Kalpana Chawla. She was an Indian origin, and she started her career, engineering degrees in India and just moved to US, and she eventually became an astronaut. And she was the first Indian origin female to enter into the space. Um, as always, we pick the first one who did special things, and she is not an excluded one. And she was an robotic arm operator for a very critical mission, space shuttle mission by NASA. She went into space and she was doing very critical missions there. Um, but sadly, when she was uh, getting back to India, getting back to Earth, um, the space shuttle had exploded due to some technical issues, and of that mission, nearly about 7% of that mission has to give their lives. She was one among them. Um, her achievements was really great, and a lot of buildings and roads and many places have her memorials we can find around the world. With that, I would like to introduce myself. Myself, Ajay, and I work for Valuation Systems, which is an automotive supplier, Tier 1 supplier. Uh, I work as a lead test engineer, where right now I automate a lot of production testing and quality stuffs, especially for camera manufacturing. And very likely, if your car has some camera, it could be from value or something gone through our production line. Um, and also some ECU manufacturing test automations. Um, in my spare time, I spend some time on developing some LabVIEW tools, which is interesting to me, and that is where this topic altogether started. Um, Door to SaaS world. Um, so this is mainly I try to bring in some of the frameworks or architecture I brought in, uh, which has worked out for me for some of the projects, both uh, in the regular day-to-day jobs as well as in my hobby time. Let's see what have been there. Stay tuned and don't forget to hit that bell icon. We always hear this sentence very often when we go to some videos, right? So be stay tuned and be smiling all the time. Let's get started. So welcome to the world of SaaS. What is SaaS? SaaS is a software as a service, as simply put as, and if you have worked with any of such SaaS services, can you name a few, some of your favorites, something like that? Yeah, something like a Jira, Confluence, and right now we are almost in the SaaS world. Pretty much all the stuffs what we are using day to day is SaaS. Very few of them is very visible, like Google Cloud or all the Google stuffs what we do or on the cloud, and Microsoft Office what we have. right now, the Microsoft Office 365 is pretty much into cloud. Uh, they have only the little bit on your PC to just show some offline apps, pretty much on the cloud now. The Azure or AWS, the Amazon Web Service. Um, these are pretty much a platform than a SaaS itself. The Azure, Google, and AWS provides a platform to develop the your software over the cloud, and Office and Salesforce. Salesforce is the very first entity I would say has been very successful in this domain when they started out. Uh, in the earlier days, it was a big question mark whether this is going to work out. Back 20 years back, uh, they are the one who started out, and as Karthik said, Confluence, Jira, all those are from Atlassian. Atlassian, and they are again based on completely on a cloud system, and it's a SaaS. So, what is SaaS essentially? So, when we try to put that in simple terms, your software is based entirely on the internet, and it's a kind of an approach where software distribution, the providers put them in the hosted in the combined servers somewhere not reachable by normal people, and they just get the clients on the client or application on the other endpoint, like either your mobile phone or your uh, pla- uh, Windows PC or whatever it is. You get a simple uh, user interface which starts interacting with your SaaS service running behind on the cloud. Your servers, databases, and all the codes, which is doing the primary business logics, sits on the cloud. You simply have a web interface or application. How it differs from our usual traditional software? Usually, right now, the primary attraction towards this is that it's a subscription model. Um, so you start paying for the service, what you get from that software on either on a regular time frame, or like monthly basis or yearly basis, or even some software is based on how much service you use. You will start paying for that, like Google Cloud Platform. And in a traditional software, you just do a one-time payment, like when you see back in Microsoft Office olden days, you just buy a Microsoft Office off the shelf for special $100 or $200, and you can use it for infinite amount of time. There is a huge difference and advantages, like the special thing I am pretty much interested in this model is the SaaS software provides a means to decide or go in a right direction what the user wants. If the user doesn't want it, they stop paying for it, and that gives us a very critical pivot point we have to make in order to achieve the better valuation by providing the better software or better service what the user want from that software. That's where I would say the when you see how the Microsoft Office, I'm just comparing Microsoft Office here because everyone is aware of it very easily, whereas even in any other model, the service model, you would see that the user experiences we achieve is greater than the traditional software. Okay, it's all good, but what does it mean to us as a LabVIEWers for if we traditionally see this, we have been using LabVIEW to connect to different uh, different entities. I would say like some software developed in some other language. We use the library nodes or DLLs or system execution to connect to the executable and execute something. Um, we always try to work along with the all different items, which is from a different platforms. You might have got some DLL from C Sharp. You still want to interact with the LabVIEW, uh, something like that. So in the same way, we were using something like ActiveX as well. Right now, the trend is changing, and we have noticed this change in trend even happening in the LabVIEW. So there are some components like web services and Python. Very recent years, Python introductions gives us a citation how the way the software entities operate is differ. We started using a lot of web services and Python, and nevertheless, we are also using the SaaS in a greater extent nowadays. For example, we we started exporting the reports uh, to an Excel sheet when the Microsoft Office was there, and it was a very great uh, reporting structure for any production environment. For each devices we test, we use such reporting generated in the Microsoft Excel and send out the Excel file. But all those are now turning into a SaaS service and databases. For example, I just simply given a Mongo database, but Mongo database is one of the popular SaaS database, but still there are different databases. All variety of databases you can get it in different cloud platforms. Um, so those databases, the data what we collect, are uh, getting into the cloud. For example, in one of my recent project where the client wanted all the heavy load data should be in their cloud. And we started pushing all the data to the cloud as and when the data is being collected in the end of line test. You might imagine that the end of line test is usually at high rate. It depends depending on the application, but end of line when it comes to end of line test, we want to do at the high rate. Still the client started wanting this data right on the cloud so that they can do the analytics on the data on the fly, and they can decide whether the quality of the product is coming out to the extent they expect. Um, so it is in that way. We are already into that level, and we are already using the SaaS. Moreover, it's a new paradigm. It's completely new paradigm, and everything is has some cycle. And this is a new cycle which has started recently, and everyone is going to that world. Let me see if there is any questions. I don't hear from anyone else. Okay. Hopefully there is no questions. getting back here. So how does it usually work when it comes to SaaS? So there would be a SaaS service somewhere in the cloud. By cloud, what do I mean is somewhere on the internet. When you connect to the internet, somewhere in the server in around the world, the SaaS service would be running, and you would try to use your end device, either your computer or mobile device, whatever it is, as a separate application that will try to interact with the various API libraries or API uses of the API keys and so on, like JSON objects and various data objects to start interacting with this SaaS service. So you usually do some API calls to the SaaS service, and the SaaS service will respond you back with some kind of data like JSON objects uh, to you, and your app will start interpreting that, display the data in some format. So here, our app could be a LabVIEW application. We can develop some application with LabVIEW as well, which can start interacting with the SaaS services. But when we started integrating this directly to the SaaS services, there are quite a bit of challenges we started facing. Um, a few challenges like very common challenge is the SaaS APIs are usually based on Python packages. If we start developing the uh, applications which uses more than one SaaS service, uh, it's very easy that we find most of the SaaS service gives a Python packages, and only few give like .NET wrapper or .NET library. Um, so if we start working with the .NET library, for example, right on the LabVIEW, it the other service will be on a different platform. But very common among them is Python libraries, which we get, and this Python library integration sometimes becomes challenging. For example, few APIs they want to use some specific version of Python. So in such instances, when we started looking at the Python node from LabVIEW, it was mentioned in the help that only specific versions of the Python is allowed, and moreover, the data structure which is going into and coming back from the SaaS services like JSON data structures are usually very complex for LabVIEW from LabVIEW point of view, whereas when we use the same platform like Python platform, the maintenance of such a complex JSON structures become much easier. And last but not least, usually these SaaS services, as I said, as one of the key advantage, all these SaaS services usually in a moving target, it keeps changing very often. The version to version releases, or you can find that when new feature, if you want, there is a new library becoming available, a new version of library becoming available, and updating the relevant information on the previous LabVIEW uh, application would be a much challenging job. Uh, yeah, Python version which can be fed into this node in the Python node. When we saw the example, we noticed that it can only support 2.7 and 3.6, and I still have a question whether the latest version like 3.8, 3.9 are still accessible through this. But all these things became more challenging, and we started thinking about trying to bring up a layer in between that, like a moving target. If you want to keep targeting that, your LabVIEW development speed should also be fast enough in order to keep targeting that. So how we did that uh, right right now is with the same entities like SaaS in the cloud and API call, API responses, libraries, and so on. Just that on the software, on the client side, um, instead of just using the LabVIEW to interact with the SaaS, right now the LabVIEW start interacting with another layer of the Python, and that layer of Python will be able to interact with the SaaS, and this will reduce much of the challenges which was faced previously when LabVIEW was directly used. So why Python layer? So the Python layer is pretty much, as I said, very easy. Uh, every SaaS product is support the API, Python API. Anyone can read, write, and learn. Any engineer or any newcomer on the team can start developing with the Python so easily. And this introduction of a small layer has reduced big challenges. One more thing is that the community, just like a LabVIEW community, how we get quicker answers from the forum, we get we have a very good community around Python as well. We can go to Stack Exchange or put up some questions, but most of the time we find answers to our question what we have in the Python. Even if we have any new questions, the responses are quite faster, and object orientation in Python is quite simpler as well. So LabVIEW on Python. So now the architecture, we went with a very simple architecture here, where just a LabVIEW and Python layers will be there. And here, for example, if it is an email service, right? If we want to check an email, what is the email on it? What we do is we send a request to this Python layer, and there is a producer and consumer on the Python layer. So producer will keep looking for the messages. It is a TCP/IP messages. It will keep looking for the messages, and it will send it to the consumer, and the consumer will start using the different Python services like email service, for example. There will be separate Python file that will have all the wrapper wrapper functions or wrapper services we need to access, and that will in turn interact with the SaaS and get back the information and send it to the consumer. So this producer consumer acts as um, the error handling part as well. So whatever the error or issues happening on the Python side will be completely handled in this layer, and it will be turned into an information that the LabVIEW can understand and start comprehending that into the LabVIEW errors. So that goes back to the producer, and the producer will in turn send the message, if it is error message as well, to the LabVIEW via TCP/IP. And on the LabVIEW side, it will start interacting that. Uh, One more thing about the object references. Probably this was in the very early time when we started. where we had only a single Python node, which has to execute a script and give back the responses. Uh, and later, LabVIEW introduced the open reference and closed reference with the Python execution node. Um, so back in that day, we were very challenged to retain the references because uh, we had to open some sockets to the SaaS service, web socket to the SaaS service, and keep that socket opened until all the interaction is completed. But it was very challenging then. Uh, and then the API object, whatever we opened, all of them were very challenging then, which I believe that it would be achievable by now, but unluckily we didn't get a chance to try with the object with the session open and close, primarily because the code structure has developed and it's better to go out with the same structure. So here is a small demo that I have in here, which shows how it really works. So I try to capture it in a small video so that I can avoid any such delays in interactions. So we will see that in a moment. So this demo, how it works is that there is a SaaS service like this is for an example, mailer send, which is an email service, for example. So how usually we have to approach doing this is we have to first figure out the API resources that specific SaaS service provides. And from that API resource, we have to figure out the specific API functions we might want to pick up. For example, few services put up a lot of examples on the GitHub, and we go and pick up some example like that for send an email, and we bring that back to that Python layer with some modification what we want or customization, and we put that in a, Python file, and there will be a main Python file that usually has the producer and consumer architecture to transfer the messages and the responses. And when it comes to the LabVIEW side, on the LabVIEW side, we make it as simple as possible. Like we just compose all the arguments to that Python wrapper in a simple cluster. And on the block diagram side, we simply interact with the direct functions, just like this. For example, mailer send email dot send simple email. So this is a function name which directly goes to that function and starts executing that function. And the server IO will send the request uh, to that Python layer, and it will get back the responses, and we put it up in the front panel what happened. Yeah, and here is that small video. So before I go there, if there is any question here, I don't think so. Okay. So let's see. I have the audio as well recorded, but I'm not sure if you're able to hear the audio. So I better explain on my own words playing this video. So when you see here, we have the main Python file, which has the producer and the consumer architecture here. So this all this runs in a parallel thread, and this initiates the TCP/IP and those connection. And on the other Python file, we have something like this mailer send email Python file, a function like this send a simple email, and all the LabVIEW requests will be sent as a JSON request, and the LabVIEW request will will be comprehended here as a proper Python request. And on the LabVIEW side, as I said, it would be a simple VI, all individual module of the VIs that can directly interact with the individual components of the Python functions. Here the request is converted to the JSON and goes to the server IO. It executes on that. It basically does everything. When this node executes, it does send the request to service, cloud response back, and everything happens like that. And for this mail send, to prove that that it does send the email, here I am running this Python code. So you can see as a GUI, which is developed off the Python, and it shows Python server running and what is the log it is happening there. And you you can basically compose everything into this simple executable. You don't even need a separate Python compiler or interpreter to run this. Once this is made into this, your SaaS service, SaaS APIs, everything composes into that simple executable. And on the LabVIEW side, if I fill up these arguments, like from to who the message should go and so on, this will send this request to this executable now, and this executable will in turn send the email. So I'm filling out the details here, like from AJ, and from my email ID, and to some name, and to some email ID, and some simple text here for like a test. And yeah, when I run that, you can notice that the logs are getting updated. What essentially has happened is it has gone to the producer and then to the consumer and then to the email, that Python file. Then it has gone to the server, and server sent that email now to my email ID. Good. So one thing to notice here is that that standalone executable, what you have noticed, um, it was really beauty that we can put all together everything into that single executable. As a lab viewer, we are used to that practice now. We want in a single executable that can do it pretty much everything. Uh, so the Python development environment usually has a visual environment and all the packages, like this email packages or any other packages, everything in a different, everything inside the environment has a different packages. And when we build this executable, just like LabVIEW executable, it will compose all the dependent packages inside that single executable, and all we need is that just to use that single executable for execution of the whole Python code. Uh, we can build the executable simply by using this command PyInstaller, whatever the Python top level VI you want, top level Python file you want to execute. And when you build it, you will get a simple executable. And that's pretty much it. Is there any questions or clarifications? Okay, looks it's fair enough. If that is all, I thank you everyone for participating in this presentation, and for any queries, feel free to contact me at the email or the contact over there in the opens. Thanks everyone, and have a great day. That's good to know, Jasper. Yeah, I'm not aware of that. Uh, so we will explore that as well. So far, we never faced such issues like antivirus. It does. We did develop this in a full corporate environment, and all the antivirus stuffs are there. Um, but luckily, we did not face such issues. We will we will try to look into that as well. Thanks for that information. Uh, do I use native Python node? No, not at all. In this development, not at all. Earlier, we used to use the system executable before the Python node was introduced, just to execute the direct Python on the interpreter using the command prompt. Later, that has turned out into such architecture. Good to know. Certifying the file. Yeah. Um, Thanks, Jasper. Yes, Karthik. I'm trying to put out this in a GitHub. I'll try to put out both the presentation and the uh, code in a GitHub, and I'll publish it. Yeah, it's quite a bit of last minute preparation. So I thought of bringing out this key learning, what I learned, which is quite useful for this community. Uh, yeah, thank you. Thanks, Karthik. All right. If there is, I think that's pretty much the questions. Thanks everyone for participating. Have a great day.